All right. Well, thank you, everyone. My name is Paul Lowell. I'm KD4BFP, and Tim, KM4EFW, is on here with us as well. You're zooming in from Pittsburgh at the moment, but we are a group of folks that are hams with all sorts of other geeky hobbies, and they just happen to align really well with something that we're calling near space. You also see it as HAB, high altitude ballooning. It's, as far as hobbies go, it's a pretty inexpensive hobby compared to what you get out of it. This image you see here is one of the first images I ever took on a balloon. This is from 100,000 feet up over Raleigh, looking down towards the coast. So it's a fun little hobby. It involves a lot of things. Probably all your other hobbies that you're interested in all have something to do with this as well. So I'm going to take a few minutes and just kind of explain HAB, and then jump into the cool stuff, which is the tech, the microcontrollers and all that sort of stuff. And then Tim has taken this a little bit further, advanced level, in that he's flown around the planet with this sort of gear, and we'll talk about various ham radio modes and equipment and all that sort of stuff. So and I guess if you have any questions, or we may be waiting till the end, or we can go ahead and do it now. Now, just for clarification, when we're talking about atmosphere, there is no line outside of maybe something that's been dictated by legal groups or Congress of what space is. The atmosphere, as you go up, just gets thinner and thinner and thinner. So what we're doing is we're sending electronics and little packages, payloads, up to 30 to 40 kilometers up in the sky. Now that's about 3 times higher than your standard jet. It is way above the troposphere, which is where all the weather is. So we're way up above the weather. And are we in space? Well, no, we're at 1/100th of an atmosphere. So you die without a spacesuit, but we're not technically in space yet, but we're close enough. We call it near space, just to have some fun with it. But we basically will ride a balloon up and do all sorts of fun stuff with it. Now, come on. So here's just a standard image of some of the things here. We've got, hey, Aurora dead center there too. So we've been launching all sorts of strange stuff over the past few years. We're sort of a club. We don't have like dues and real meetings. It's more of, hey, I've got a crazy idea, and somebody else will have the equipment or the tank or the time, or they want to chase or something else. So we just kind of join in on each other's projects. So it's a real easygoing kind of club. So if any of you folks are interested at all, feel free to join us on any of our chases, or if you've got something you want to fly, just let us know. We've done everything, we can set up cameras, Geiger counters, we've got biological experiments, radio experiments, all sorts of stuff. Now, we've also done a lot of school groups, school launches. This is one from 10, 15 years ago. It's us filling a balloon with helium front of a school. The kids helped make a little payload, and we did this flight. Nowadays, though, we've transitioned, because back in 2007, the US got rid of their strategic helium reserve from, trying to prevent the Nazis from getting it for their dirigibles. And so now helium is pretty rare, difficult to get hold of, which means it's expensive. So by using hydrogen, we can launch for about $20 worth of lifting gas. So that big balloon you see there is a big latex bag. It's about $50, and add about $20 worth of lifting gas, and you've got a flight. So that's pretty cool. Oh, by the way, for those, as some of you may not know, helium, the reason why it's rare is we didn't really even know it existed on this planet when it was first discovered. It was first discovered on the sun. That's why it's named after the sun, Helios. it wasn't until we started pulling oil and natural gas out of the ground that this other weird chemical was bubbling in with it. And come to find out that those are just alpha particles from natural decay underground. So if it's, on our surface, it's going to float away and leave the planet. So the only helium we really have is something that's coming up through natural gas and oil reserves. So I'd rather leave that for real science, for cool stuff, and not just wasting on a balloon. Now, these weather balloons are nothing new. The National Weather Service has been launching weather balloons ever since their inception. There's about 1,400 weather balloons launched in the US every week. So, matter of fact, the Greensboro Airport launches a weather balloon every morning and every night. So with all of that information, we can plot this data, which means that there's free websites you can go to where you can key in all this information about your flight, when exactly you're launching, where you're launching it from, how heavy is it, how much gas you're putting in, and so on. And it will show you a projection of how the flight should go, all things being equal. So if you notice some of these graphs down below, the yellow is the prediction made by this software. Again, it's just on a website. You can just plug it in and go. The blue is the actual flight recorded with our ham radio gear on board, GPS trackers and so on. So it's pretty amazing how close it can get. So we've got, in the summertime, when the jet stream is mostly north of us, it's mostly up in New England, we end up with flights that can stay within the county or stay within RTP. It's not unusual to have a flight in July or early August that lands only a mile or two from where you've launched it from. And that's after going to 100,000 feet. But in the wintertime, even this time of year, if you launch in Raleigh, you could easily land it in the ocean. So you have to be careful and also be aware that those predictions, flight weather predictions, are based on current models. And as you go forward in days of prediction, your prediction accuracy goes out the window. So we were talking earlier about doing some kind of, various public launches and so on. And that's, you often have to wait till the last day to really figure out where the thing is going to land. And if you're going to do a public launch at a certain place at a certain time, and it says it's going to land in the ocean, then what do? Do you try to make your balloon trip much shorter? Do you try to terminate the flight ahead of time? There's a lot of little things like that you can play with. Now, we have done these for the past couple decades. We've got schools that will set up a mission control site where you can watch the flight while it's underway. If you notice in the upper right there, that's APERS. That's apers.fi. So any of you folks that use APERS on ham, that will look very familiar. And you've probably over the years seen a lot of our balloons go by overhead. The image in the lower right was taken during the big solar eclipse that we had across the country. And yeah, we started a little idea and it kind of got out of hand. We had a lot of balloons up over the US that day. What's funny is the week after the eclipse, there were an awful lot of videos on YouTube with people talking about UFOs. Imagine that. So these are examples of some of the things that we've done up there with just cameras. Flying during a hurricane is kind of interesting. Get some really neat photos of the bands and that sort of stuff. We've done some interesting videos and movies that you can see out on YouTube. We've made it to 142,000 feet, all on video. I took a glider up for a 5 or 6 hour flight across North Carolina. It was a completely uncontrolled glider, just a cheap styrofoam toy that happened to stay aloft for hours and hours. And we've got beautiful video of all of that. So a styrofoam glider traveling at 480 miles per hour. Yeah, we can do that. So really fun up there. And of course, I have to throw in Space Ducky as well with some nice thunderstorms in the background. Now, from up there on a clear day, you can see into the neighboring states. You can easily see off the coast. It's on, you on an overcast day, completely overcast day, there's really not much to see up there. It's just a white ball with black sky. But again, we are above a majority of the atmosphere, so Raleigh scattering doesn't affect us around there. So yes, you can actually see stars in the daytime if you point your cameras in such a way that the auto iris will pick that up. So I've been doing a lot of flights at night as well, and capturing the SpaceX launches from Florida, and when they land on the drone off the coast of North Carolina and all that. I've got all that on video too from a nighttime view, but it's beautiful up there. So this is a typical view of about 100,000 feet over Hillsborough this was taken at a Maker Faire flight. So this would have been in April about 5-10 years ago. Now, as you ascend, as I was saying earlier, the atmospheric pressure drops. So if you're using a balloon, let's say these typical latex balloons that are sealed off, and the atmospheric pressure on the outside decreases and your inside is kept stable because it can't leak out, then that balloon that was only about 5 feet in diameter at launch can grow to about 35 feet as the atmospheric pressure drops. So what you end up with, and these are 3 successive frames from a video camera, so they're 1/30th of a second apart. This is that poor latex balloon that's now 35 feet in diameter, disintegrating. Now, these are made out of natural latex, and the critters in North Carolina just love to eat this stuff. So it's all natural, so it biodegrades really quickly. I've been really surprised with that. Problem is, you now have your payload, your cool ham radio gear, your electronics, your camera, whatever else, at 100,000 feet up over North Carolina with nothing holding it up. So it's going to fall back to Earth. Now, there's not enough air really up there for a parachute to do much of anything. So during this stage, it's going to drop 60,000 feet in a matter of minutes, and there's not much you can do about it, but hang on. So you want to make sure that your design can handle something like that. The parachute acts merely as a sea anchor at that speed and at that altitude. So it can kind of keep you going in the right direction, but it's really not going to slow you down that much. But again, it is pretty up there. From up over Raleigh, we can easily make out Myrtle or, Wilmington, the Outer Banks, all of that sort of stuff. And there's a little piece of balloon scrap in there. This was taken just a quarter of a second or so, half a second after burst. So then comes the fun part. You've got this thing coming down on a parachute. The parachute isn't working much at all until it gets to about 40 or 30,000 feet. Then it starts digging into the air and starts slowing down. So at this point, you're driving below it in chase cars. It's got all your favorite ham radio gear on board. It's transmitting either to APERS or to a site that we use a lot that's out of the UK called HAB, High Altitude Ballooning Hub, that takes APERS as well as other receiving telemetry and presents it all in a nice little page. You'll notice this image also shows the chase cars on there too. So it's a lot of fun. And from the balloon, you can sometimes see the chase cars in the video. And several times I've managed to watch the balloon land. We always want to try to catch it, but I don't know if that's ever going to happen. But like model rocketry, of course, if you're going into a large field, it will land in the only tree in the field. Or in this shot, it came to a halt with the winds and landed right in this little thin strip of woods. That's always the case. And we like to thank Tim, because Tim is pretty amazing at getting these things out of the trees with his bow and arrow or other crazy things that we've tried over the years. We have found, you notice a lot of kids in this. We do a lot of school events, but we also like to bring the kids along because it makes recovery a lot easier. When you're showing up at some random house in the middle of Eastern North Carolina, and have kids knocking on the doors, the tendency is for the shotguns to go away and for people to be really helpful as you go and get a small Tupperware box or whatever, a styrofoam container out of their backyard. So we are kind of, dropping this at a almost random location in Eastern North Carolina or wherever. So it's the kids are really helpful with that, and they seem to have a lot of fun, especially when they've got things that they have sent up to the edge of space. for school or whatever else. So basically, we've got a hobby that is a mix of a lot of different things. And it's a complete blast. It is affordable. We use hydrogen, again, because we're running out of helium. There are FAA regulations. People always wonder what the deal is with the regulations for this sort of thing. There are specific regulations, but if you have a payload that fits certain requirements, then there's no licensing and there's no even communication much needed with the FAA. Of course, you don't want to fly near airports, and you don't want to send up anything that's gonna smash a windshield of a plane. You don't want to do, you don't drop bombs or anything from it, because again, we're talking about incredible speeds. So also, the lighter the payload you have, the higher you can get. So again, if you have a lightweight payload, then you can put less gas in that balloon. That balloon will then be able to stretch further, and you'll get higher altitudes with that. So if you're going for maximum height, then you want to try to come up with something that's really lightweight. And that's fun in itself if you're designing electronics and so on. So we try to keep, I don't think I've ever launched anything that's over 3 pounds. So a lot of these payloads, you can get really amazing stuff out of very lightweight. We are at the mercy of the jet stream, but we have tools that is taking data from the National Weather Service that allows us to do these kind of flights. And what we've been talking about up to this point has been the typical latex balloon flight. And it's usually 2.5 hours up and about a half hour, or maybe 2 hours up and half hour back down. There are, though, super pressure balloons we'll talk about a little later on, where the balloon doesn't expand, which means when it goes up, it gets to a point where it hovers and basically floats. And from there, if you do things right, you can travel the world. Now, as far as microcontrollers and electronics on board, historically, those have been mostly used for tracking. We've gone crazy with it since then and have done a whole lot more than just tracking. So in the old days, we were using typical ham bands for doing what we're doing with this stuff. Started off 20, 30 years ago with RTTY, which equipment that we're using for instance, tracking model rocketry and high power rocketry and so on. We have since, in the past 15 years, moved to APERS because it is so very common everywhere, especially in the US. There are some places, though, for instance, in England, you can't use APERS in the air. So they've had to come up with some ways to get around that. So if you are sending something around the planet, you have to be careful that you're not transmitting your APERS packets when you're over England or a few other countries. There is Whisper. We'll talk about that as well. That's really a protocol for watching propagation. But if you hack it and just use it right on the edge of what it was really intended for, you can use it as tracking as well. And then there's something that I've been really having a lot of fun with lately. This is in the past 5 years, and this is the LoRa protocol. It sends a bunch of chirps across spread spectrum, and with it, it's able to send a lot of data, dramatically more than APERS or standard RTTY. And the chips are proprietary, but they're also dirt cheap. So yes, they're proprietary chips, but you can get them for $3 or $4, which allows you to transmit 100 milliwatts and reach several states with reasonable speed. So there are some things you can do with ISM. So for instance, when we do school flights where they don't have ham operators available, they can try to do LoRa with a 915 megahertz in the ISM bands. Some folks, especially during the eclipse, were trying Wi-Fi and in bands like that, in the 2.4 gig and 5 gig space from those altitudes. It's kind of, when you're dealing with microwave, you have to really point at each other, and that's difficult to do unless you're in a car directly below it or something like that. And of course, the cell technologies, they say don't use a cell phone in an airplane and all that. And we found with our flights, you really can't use a cell above 2,000 feet or so. The antennas are just pointed at the ground, And the cell stuff really doesn't work much at all at those altitudes. So not only are we putting cool gear in the payloads, but we also have to have stuff on the ground. So whether we're in a chase car or home base stations or whatever, we've got ham gear that we have in those locations. You can see I've got a Raspberry Pi that does, let's see, it's got an SDR and several other devices on it. So that thing will receive 3 separate frequencies simultaneously and post them all out on websites, whether that's apers.fi or HamPiE or any of those other things. So there are folks that have really gotten into this hobby and have developed an awful lot of code and sidecars that go on top of Raspberry Pis or additional hardware. And it's all available out there. You can go to GitHub and get all your software and play with this stuff. They even have complete base station setups that look really cool. Real nice user interface. And of course, this website, this HamPiE website that allows you to track all of this stuff. And it has since grown. Just be aware there is a version of HamPiE that is used for the National Weather Service balloons. The 4 balloons that are launched every day in North Carolina, or the 92 every day in the US, because those will land in somebody's yard, and there are people that like chasing those. So they'll go grab them out of the yard and send them back to the National Weather Service for recycling. But this has really grown since then. Now, some of the things you have to keep in mind when you're designing it, and this is part of the fun, is it's going to go on quite a roller coaster ride for temperatures. So you've got a box with your payload that you're going to launch. You're getting everything ready there on the ground, and it's late July. It's 80, 90 degrees. So inside the box, it's 110, 120. So your equipment has to put up with that. But then as soon as you launch it and it travels up, the air temperature starts dropping. So at around the altitude of jets, it's about 40 below. And if you do it right, everything's fine. Just be aware that once it gets above into the stratosphere, it will start warming up a little bit at that point. The sun really helps. You're above all the clouds, you're above the weather. So it'll warm up to a decent temperature. But then when the balloon bursts, it's going to have to go back down through that cold layer again. Now, there's one additional consideration with this. Let's say you've got a styrofoam box, one of those, a cooler, and you've put your electronics in it with your nifty camera and all of that. Your batteries are all inside. When you head up, when you float up, the air is lower, air pressure is lower outside your payload. So the air is going to leak out of your payload as you ascend. So that by the time the balloon bursts, you're only at 1/100th of an atmosphere inside that box. And that's okay. But as soon as it bursts and you start falling back down, that air pressure is going to increase. And sadly, where it's going to increase the most is where it's 40 below zero. So if you notice on the graph here, the blue line of outside air and what happens inside, you suddenly have an inrush into this big empty styrofoam box with all your batteries, and your electronics are starting to frost up. And we've been to flights before where we opened the payload soon after landing, and there was frost buildup inside these styrofoam boxes. So there's other design considerations you can have for dealing with that. And I mention this because the lower graph there shows battery voltage, and battery voltage will take a dip as the device ascends, but again, after burst and it falls back down, it really gets cold, and that battery can drop down. And as you know, most microcontrollers, if you're running most microcontrollers, 3.2 volt is a cutoff. Something around that range, right below 3.4 is when they'll start running into problems and dying out. Now, once the payload hits the ground, it will warm back up again, and that will be fine. But the question is, will your trackers know how to handle all of that? I also want to mention that I ran into an interesting thing with a particular type of 2-meter whip antenna. There's 3 images in a row down there, and you can see a rubber ducky on one side of the image, but there's a whip antenna. I think it's made out of some kind of pulled steel guitar string kind of thing. And we found that around 30, 40,000 feet, where the temperature was 40 below, that little antenna coiled up into a little ball. Some kind of bimetal thing happening. So it was a perfectly good antenna anywhere but right around those altitudes. It would curl up in a ball and then we would lose signal. So a lot of really strange things that we discovered during these flights. We've run into lots of radio interference problems, mostly having to do with GPS. So you've got a rather inexpensive ceramic GPS antenna, chip antenna at those locations, in your box with your microprocessor, which of course is oscillating and giving off all sorts of RFI. But also if you have those little inexpensive webcams or little dash cameras or whatever they call those things, those give off a lot of RF as well. And we've even found that the power supplies, the step-ups in things like the USB charged batteries, your little battery banks, those can even give off enough whistle that the GPS antenna can run into problems. So when we're building our payloads out, we try to keep the cameras far away from the GPS antennas, and I try to put a lot of aluminum foil. I usually take aluminum foil and put packing tape on either side so it makes it non-conductive, and use that as a shield to try to shield as much as we can to keep that from being a problem. And of course, we're talking about when the balloon pops and the thing is at 100,000 feet and it's just free falling, it's bound to smash into what's left of the balloon or maybe other payloads that you have in a string, and it's going to spin around and fall at 400 miles an hour. So it can be kind of violent. And if you've got a standard, Energizer Ultimate lithium batteries, which are awesome at low temperatures, by the way, in a typical battery holder, those little battery holders have a spring on the ground, and the plus side is just pushed up against a metal plate. Well, oftentimes at burst, there'll be enough jolt that it will actually, because this is a mass and it's moving, it will pull it away and you'll lose power for a millisecond or half a second or something. And that's just enough for your Raspberry Pi or whatever device to completely lose its mind. So there's a few considerations there as far as jostling. And also, when this thing slams into the ground, even under a parachute, it may reboot as well. So we're at 1/100th of an atmosphere. We talked about that mostly with cold. I haven't run into any problems with actual lack of atmosphere as far as components delaminating or things like that. That's been pretty straightforward. Another thing I haven't run into much trouble with is radiation. Now, funny enough, the highest radiation you get is about the altitude when you're in a jet. That might not be very comforting, but it's called a Pfotzer maximum. And that's because all those cool high energy particles coming in from outer space are pretty few and far between. So when you're way up there, you're not really protected by an ozone layer, but there are also not many of those particles coming by. But when those particles get down to about 30, 40,000 feet, they hit air molecules and it starts a whole chain reaction. It's, it's like breaking your billiard, right at the beginning of a game of pool. All those other air particles will suddenly get shattered and go off flying, and you get a high amount of radiation at that point. So when we fly Geiger counters, it's always fun to see that the worst place to be in space seems to be right at jet level. So sorry. There are commercial flight computers. There are a few handful of companies here that make these things. Some were maybe not intended to be used in near space, car trackers from China and so on. But a few were designed originally for tracking high power model rockets. But we've been using them probably 20 years ago. We started when we were first doing these high altitude balloon flights, we were using those type of systems. So we have a 5 or 10 watt APRS transmitter, which I tell you from 100,000 feet will light up about 7 states worth of APRS receivers. So please, if you're using APRS on the weather balloon, make sure you turn off all the repeater modes, the wide modes on your APRS. Otherwise, you will just completely melt the whole East Coast APRS network. Not a nice thing. But there's also boards that you can buy that just simply slip onto a Raspberry Pi. So, and of course, all the code is available for all of these things, so you can play around with them. But you can also just build your own from scratch. Dave Akerman is a gentleman who flies a lot out of the UK. And remember, in the UK, you can't put APRs up in the air. So they've had to come up with all sorts of other modes of operation. So he's got a project, and you can go and buy the daughter board yourself and put it right on your Raspberry Pi, or you can just make the thing from scratch. He's got a wonderful set of blogs of all sorts of amazing things that he's done with the concepts, and has all of his software out on GitHub. So you can go out there and build these things all day long. And the most simple one is to take a Pi Zero and add your favorite little Pi camera to it, and a GPS module, which is about what, $20 from China or something like that, and a LoRa board, which again is under $5 for this tiny little postage stamp looking LoRa board. Solder it all together, put your favorite power supply on it, and it will send back via kind of a slow scan technology a JPEG image from the edge of space. So it will take multiple photos, and then every minute or so, it will look at all those photos and see which one has the largest file size, which basically means it has the most content in it when you think about it, and will transmit that, as well as all the latitude, longitude, altitude, temperature, whatever else you want on there, transmit that all back to home. And you can pick it up with a similarly priced, we're talking something under $50 as a receiver, that you can put in your car or have at your home or whatever. And of course, if you're connected to the internet, let's say it's a receiver at your home, then you can receive those packets and transmit them out to the website so that everybody else in the area can follow along. They can see the live images and they can help chase with you. So it's a lot of fun, and it's all out there. It's really inexpensive. So if you're looking at a project to do with a Pi, go for it. It's been awesome. And the advent of LoRa as a transmission medium, it's really helped them out in England. So they've kind of run with it. And I was looking out at one of these Alibaba's or Chinese electronics stores, and came across this thing called a T-beam that is a 70 centimeter or 915 megahertz little board. And it has its own battery pack built into it. It has GPS, it has LoRa, it has Wi-Fi, and a microprocessor, and a whole lot of pins, individual pins that you can solder stuff onto. So I was like, I wonder if, and I flew with this a few times, had a blast with it, told Dave about it as well. And he's taken his code that has stuff like landing approximation information and all sorts of other cool stuff. And he's built that into these boards as well. Again, this is a $26 device that you can load free code into, and you have your own tracker unit that does a bunch of other stuff. And of course, the code is completely open for you to play with, and it can even do Wi-Fi. So maybe have it talk to something else in your payload with Bluetooth, Wi-Fi, or maybe once it's down and stuck in a tree, you can pull the photos off using Wi-Fi instead of having to pull it out of the tree. I don't know. But Dave has also taken these wonderful little LoRa watches and has built a receiver and tracker into the watch. So you can walk out into the field and look at your watch and find out where your payload has landed. It's a lot of fun. I know I've also flown a lot of Adafruit products, a lot of the feathers, a lot of those kind of microcontrollers. Down at the bottom of the image there, you've got an Adafruit logging feather that has a SD card on it for logging telemetry, and a little Bluetooth or Wi-Fi board on it. So it has the ability to transmit, talk to other devices in the payload string. So let's say you've got a one box that has all sorts of telecom to the ground. You can have this thing in another location in your payload for controlling something else, and have them all talk back and forth to each other with Bluetooth. So you're only limited by your imagination on this. We've been very happy with LoRa. Yes, it is a proprietary protocol, but it's so dirt cheap. that it's not like you have to pay hundreds of dollars for their special chip. They're just practically giving them away, and it's a neat little protocol. You may come across it already on the 70 centimeter band, and I can definitely see it filling up the 915 band in this country. Now, we've been talking about LoRa and APERS, but there is an additional protocol that we should probably mention. I don't know how many of you have done Whisper or used Whisper reports, but it's basically a protocol that was set up that at a certain time, every few minutes, beacons will go off around the planet, and people will listen to those beacons and report their signal strength and all of that sort of stuff in. It's for long wave propagation. So you see them on a lot of different bands, but 20 meter is, I think, where we've been making use of it the most. So it reports the transmitter's location in grid squares. So it's kind of crude, but we're talking about something across the entire planet. So if used in this kind of hacked way, and we make sure we're not upsetting the entire Whisper community by doing this, but it allows us to transmit a 20 meter general approximation of a location that can be picked up around the planet. So, and there's a lot of uses there. So at this point, let me go ahead and have Tim jump in and talk about some of the fun things you can do with Whisper and other protocols on a bigger scale.
Hey guys, so I just wanted a couple things to start with. So the Around the World project actually started with a kind of a gentleman's bet for my son and his best friend in high school their senior year at lunch. My son started, like he always does, bragging about he could fly a balloon around the world. And his good buddy says, well, I'll bet you $500 that you can't fly a balloon around the world. And they said deal. And they talked to the principal was all in on it. We kind of made it a school project. And then my son went off and did about a 12-page research paper on how this could be done. And I've actually, we talked about, Paul and I've talked about it for years around the dinner table with my kids. So he had that thing in his head. But he went out and did some research. He found the guys who have done it and some hardware to use. And then I supplied the money and the muscle. So it basically only took about two things you need is a ability to compile some Arduino code, a really good gram scale that we got from the science department at their high school, and a little bit of money. And we did the thing in the first try. What Paul shows here is kind of a variant of what we have done. It's very simple. It's a thin film semiconductor solar panel and a couple super caps over there on the right, and a little board, this board incorporates both Whisper and APERS. And the beauty of both of them together is Whisper can be heard pretty much. Our longest ping that we've gotten with this little board transmitting at 10 milliwatts, 8,000 meters. So a guy, this thing was over almost in Asia, and a guy in South North Carolina received it on his backyard antenna. Now, that's the beauty of it. The downside of it, what Paul said earlier, was the packet is very small, about 50 bits, right? And in that little bit of information, the only thing we have is we send our transmit power and our grid location, which is basically a 100 by 100 mile square of the Earth. The Earth is just divided in these 100-mile squares. So the accuracy isn't that great, but when you're going around the world, 100 miles is great. That's elegant. And then, so that's the low power. It's 10 milliwatts. It has a 30-foot antenna. That's kind of a downside. But then it also has, on this little board here, it also has a APERS transmitter, which transmits at 0.5 watt. The beauty of APERS is we get a whole lot more telemetry. We get very accurate location within a couple meters. We get altitude within feet, and we get temperature and value. So we kind of get the health of the system when it's over a APERS station. So across the U.S., APERS all over the place. across northern or the east, the western tip of Africa. There's vapors. Once you get into Asia, there's no vapors. So we get quiet in Asia. So this is some pictures of what the system looks like. In the middle, lower middle, is actually that is the unit that we flew. The whole unit weighed 22 grams. We used a big balloon, which was basically like a dry cleaner bag, but it's made out of some special mylar that's UV resistant. Now the scale comes in order for this thing to work, you have to fill it with just enough lift to where it gets up into the atmosphere, the air gets thinner, there's less lift up there. At some point, you end up getting neutral buoyancy. So it's basically just floating in the atmosphere. So to do that, you need to give it almost exactly 2 grams of lift. So if you give it just 2 grams of lift, it gets up to about 40,000 feet. It gets into the jet stream and it just stays. So the whole 60 days plus we had it up there, it varied about 6,000 feet. It went from about 38,000 feet to about 44,000 feet. And it just floated in the jet stream. We clock speeds up to about 400 miles an hour with this thing flying up in the air. There are some variants. Paul showed them on the left of the slide. Something we've been trying to fly, we'd like to fly next. It's actually a much smaller, lighter board. The board we used for the flight was about 8 grams. This board on the left is about 2 grams. And just the beauty of that is we can use a cheaper, smaller bag to fly with, but it's only Whisper. But on the good side, this board, this software is kind of hacked on Whisper a little bit better, where we can get APERS like telemetry out of a Whisper packet. What they do is they kind of pack 3 packets or 4 packets in a row. Each packet has a little bit of data in it, and you got to string the packets together to get your more accurate data. So that's it. So one more little side note. So his buddy bet him $500. Alex won the bet, but then his friend never paid. His friend actually worked all summer to save up the $500. And that day he left for the Naval Academy, he came over our house and paid him. And he went off to the Naval Academy. So now someday I think he's going to be flying F-16s. The kid's just stand-up guy. But that's it. That's what I got, Paul.
So it's, as you can see, if you're really into doing surface mount, tiny little surface mount stuff, there's room in this hobby for that as well. I know, Tim, you've made a little reflow oven, microcontroller controlled baking system for doing your soldering and all of that on these tiny little boards. And we're using the smallest little surface mount things where you practically need a microscope to set the parts in. But and down there in the center image there, that is the QRP Labs Light APRSW, which again is a board you can buy, and they give you the code, and you can go in and modify the code and upload it and all of that. This one, the purple one, you program it all up, and once you get it going the way you want, you snap off that the little wing on it, which is your programming interface. And because there's no reason to fly a programming interface, and that saves a gram or 2 right there. So again, this is really the extreme level of high altitude ballooning, using 30-40 gauge wire, bell wire as your antenna, and using just solar power and super caps to keep the microprocessor going. And in those environments, you really have to for instance, if you've got APERS going and you can't use APERS over England, that means your board, your processor, when it wakes up in the morning, gets sun, it needs to figure out where it is. And if it's over England or over other certain countries, don't use APERS. Or if you're over Australia, change the frequency to the Australian frequency and transmit there. You've got all this sort of stuff that you can put into the code as far as geolocating that. So it's quite a blast. I think at this point, you can find us at ncnearspace.org. We have a lot of different flights there where we show our equipment. Dave Akerman's URL was in there earlier. He's got a great blog where he's flown all sorts of stuff and has all the code and builds and all that sort of stuff. We're available for if you need to ask questions, just send info@ncnearspace.com or .org, I'm sorry, and or hit us up for questions on doing this stuff. And we're fly every now and then. We have a Google group where we post upcoming flights and stuff like that. And if you guys have any flight ideas and want to sponsor a flight or put together and do it yourself, just let us know. I've got a big old tank of hydrogen that I can get about 2 flights out of it and then refill it for $35, I think, to get it refilled. So it's a fun hobby. So thank you guys for your time. Any questions?
Thank you so much, Paul and Tim. This was a fantastic presentation. We really appreciate the time. And I can tell just by looking at the faces of people during the presentation that I was not the only one enjoying this. I think we all really, really enjoyed your talk. Do people have questions? Just unmute yourself and shout out. Ben.
I have a question, please, about how you calculate the amount of free lift. You said 2 grams for the high pressure balloon. How do you quantify the amount of gas you're putting into the balloon?
It's simple but hard. Maybe I can say goes both ways. We really just use a paper clip on the end of a string that's tied to the cell, to the balloon, and you fill it up with some hydrogen. You put it on a scale, overfill it, because this balloon is really never filled. It's only just a little bit of a ball of hydrogen at the top of the balloon at any time when it's on the ground. And you just slowly bleed off hydrogen until you get, within a thousandth of a gram of where you want to be. Now, the problem with it is there's variables. One of the big variables is wind. They can't have any movement whatsoever. So we actually did this inside the school. We did it in our science classroom. We shut all the windows, and then we start filling it, and the air conditioner kicked on. So we had to get facilities to come in and shut the air conditioner off. So that once we got that all quieted down, then the fact that it's hydrogen inside the school, we only used what I did was I filled 2 30 pound, or were they 5 pound little propane tanks. You can buy empty propane tanks at like Home Depot. They're it's already a vacuum in them, and then you can just fill from your big tank. Paul has like a 200 cubic foot big tank. We didn't want to lug that thing. It's about 100 pounds. I didn't want to lug that inside the school, and I just didn't want to have any kind of liability with that thing in the school. The hose cuts loose, and you got 3,000 psi hydrogen flying around. Maybe not pretty. So we just used those 2 tanks, and they're low pressure. They're only about 30 psi. We basically dumped both tanks into that cell, and then we bled off the hydrogen inside the room until we had just to run the hydrogen. And then you're using that hydrogen to seal it off. And once that's done, everything else is pretty simple. We just take it out and slide.
What kind of testing did you do with equipment beforehand?
No testing.
Really?
No, I'm just kidding. So Paul, and this has so many facets of all kinds of different stuff. So Paul showed the software-defined radio, SDR. So you buy a $30 software-defined radio. You can tune that up to listen at your 20 meter band. And so we take the thing outside, set it up in a tree, get the solar cells pointed towards the sun, and then go back inside and listen on the equipment inside. And we also, as a test flight, we actually put this on the bottom of a high altitude balloon, and we tracked it that way. So we did one test flight where we put all the same apparatus with the solar cell, everything, way down below all the other RF on a high altitude balloon. And it worked up to about 45,000 feet. But what happened in that experiment, there's like those transition layers in the atmosphere that are very turbulent, and it went through one of those transition layers and ripped apart. It was just not designed to go up that high and cut through those layers. And it's also not designed to go up very fast. At a 2 gram lift, I mean, this thing just, you can't even see it floating. It comes up very slow. You know, with our hot air balloons, they're going up about 1,000 feet a minute lift. So they're screaming. So all that coming through the atmosphere ripped it up. And even with that experiment, we got one guy in California posted the whisper packet. He heard it from the East Coast, not California. So once we did that, we knew it was pretty good. And then we flew it. So pretty limited testing.
I have another question for Paul. You mentioned that you've said both you can use Wi-Fi within the payload, but also sometimes RF interference causes problems with the GPS. Do you just have to shield things strategically and test that out? Like, how do you know what can talk to what without messing it up?
Yeah, that's a part of the challenge. GPS is down in the 1 gigahertz range, and so you basically have to worry about harmonics. If you're doing anything with Bluetooth or Wi-Fi, I usually try to keep it at 5 gig, or Bluetooth is down at 2.4 and it's rather wide. So we've done a bunch of different things. I always try to put my GPS antennas at the highest part of the stack and have a layer of aluminum foil between them and everything else. So they're just looking up into the sky, and try to keep everything else below it. And distance, inverse square is a powerful thing. So distance helps the most. Aluminum foil, or this kind of, here's a Raspberry Pi device where I've got this cool copper tape stuff. So this is an old microchip container with a Pi camera and then a whole lot of this stuff taped up. So anything I can do to keep the RF away from just that GPS antenna, keep it as far away from as possible. The biggest thing I found are the cameras, as they have a lot of whistling at different frequencies. 2.4 isn't too bad because it doesn't have a clean harmonic to the 1.7 that GPS uses. So we've looked out there, but having a spectrum analyzer doesn't hurt either. And now that you can get a spectrum analyzer for $100, that's kind of nice. Those little toy spectrum analyzers are pretty useful, or even using your SDR plugged into your Raspberry Pi or into your laptop can be useful for trying to find out the sources of things. What we often find is if you can download a free GPS app for your phone that shows you all of the satellites and your signal strengths, and you can hold it outside and see the signal strengths, and then bring it next to your payload and watch the signal strengths dive as they get close to it, and you'll see where your problem is. And that's a real quick and easy way to try to figure out what you need to shield.
That's a really good tip. Thank you.
Yeah, our biggest problem has been those Chinese cameras, or any camera, low-cost cameras not FCC certified. They just stream at 1.5 gig.
That's really surprising. That's really good to know, because that's the last thing I would have expected to be the thing causing the interference. I wouldn't have thought of a camera doing it.
It's the near field that kills you. You take it 3 feet away and it's all good, but you put it 6 inches away and it just doesn't work. It's just long.
Yeah, I don't use multi-$100 GoPros. I mean, you get some great pictures from them, but I know this thing is going to land in a tree. So I have a tendency to, I don't know, this camera is $70. Do I want to splurge on that? So I use dirt cheap keychain type cameras, and there are a lot that have been, thankfully, because of the drone hobby, there are now some amazing inexpensive drone cameras that are not only lightweight but high quality. And I've got one drone camera that's used for racing drones at night, and that one of my most recent launches was a flight at night filming SpaceX, and I've got nighttime color images, and it's just amazing stuff. But again, the thing is so noisy, you get it anywhere near your GPS receiver and you're out of luck. We've had some cases where we've lost contact with the payload and we had to wait for the battery to die out on the camera. And once that happened, then we started picking up good GPS data again.
You've never had problems with batteries. The problems with batteries all come from cold, not from depressurizing. You've never had a battery.
Right. I haven't had any problems with depressurizing. The Energizer ultimate lithium is the go-to for temperature, low temperature, but I honestly use a lot of lipos. What I do though is instead of the big white styrofoam box with a lot of airspace inside, I do this trick where you take a clear Tupperware box, something, standard Tupperware box, and fill it full of black foam, the foam that a lot of electronics come packed in. And that turns it into a little terrarium, a little greenhouse. The sunlight, again, up above the clouds, you got a nice sunlight all the time, right? So that comes in through the box and warms up inside, gives you a few extra degrees for free. You don't have to put a heater in. And then right in the middle of it is where I bury my LiPo batteries. And just always go a size larger than what you think you're going to need because of that cold temperature up there. And we've had some really close calls with the temperature. That 5-6 hour long airplane flight was one of them, because it was hovering 0.2 of a volt above the shutoff point, and it was over I-95, and it still had another half hour to fly. Flew into a thunderstorm and got into a warm airspace, and we managed to recover that thing. But it was a close call. But these type of batteries seem to just work at all those temperatures, so that's nice.
You
just got to tape them in then. Is that what you do? Just keep them from coming
well,
out?
I add a super cap to account for them moving, or what we often do is solder, which is a pain, soldering onto the contacts. But in something like this that's got a battery holder in it with all those springs, I've got a 5 volt, here's my Raspberry Pi. I've got there, here's your power plug to plug into your Raspberry Pi right there. That's how I turn it on. I plug it in. Well, there's my my super cap, and this thing will honestly run this for 30 seconds after I turn off the power. So sometimes I do have to pull it. But the entire transmitter for LoRa is a tiny little chip the size of a postage stamp, and it's dead simple to deal with. And any of you that have worked with any ham radio frequencies with microcontrollers know these little metal shielded cans that are RF generators for various things. This LoRa stuff is just so simple, and there's so much support out there, so much stuff on GitHub on how to use them, that it kind of, it really makes sense to just use a board like this where you've got a granted, there's a lot of hot glue holding it all together, but you've got your Pi, you've got your, I had a header on here because this is an experimental thing, but normally you just solder your little LoRa board, your camera. I've got, your nice little temperature sensors. Oh, an outdoor temperature sensor for reading the temperature outside the payload. And GPS module is way far away in extra shielding. So yeah. And again, if you want to go simple, these little LoRa boards are amazing in that they're $25. And they come with the GPS and your processor, and of course the processor is the one that the ESP that does Wi-Fi, so you can do Wi-Fi and Bluetooth built in. And hey, look, a battery, 18650 battery holder on the backside, and no springs. So this is, to make this work, you load my code, turn it on, and launch. So it's dead simple. And of course, you've got all your extra pins. So you want to wire up a temperature probe, or you want to, I don't know, do something wild at altitude with it. You can, and don't forget, LoRa is a transceiver, so you can transmit to it as well. So if you're on the ground with something that can kick some wattage and aim it towards your payload, there's an Adafruit feather with a LoRa board onto a 915 megahertz Yagi, and hang it out the car window and transmit your command to the payload and say, drop the balloon now, burst the balloon now, and come on down, or whatever. And I suppose we can get it to the point at some point where we'll say, you're about to land in the swamp, retract the parachute for a minute or something. We don't want to get into the whole drone thing, because that's limited to below 400 feet, but you could do some other things where you're like, make the parachute less efficient for the next 30 seconds. Maybe that will make you drop sooner or something. Who knows? So we can have a lot of fun with this.
Wow.
And again, all the code is out there. So GitHub is a wonderful thing.
Did you have another question?
I was just going to ask, have you put in the implementation of cutting down the payload if it looks like it's going out over the ocean or anything out of range?
I usually don't bother with that, but yes. And one of the things I've actually done with that is I've changed it a little bit to not only be able to cut down the payload from the balloon, but also cut down the payload once it's in the tree. So to be able to send a signal to the payload for cut down when it's just the payload, and then that leaves the parachute up in the tree. But and it's been hit or miss with that. But yeah, in some countries, their FAA requires flight termination capability. With the writings for Part 101, the FAR requirements for the FAA don't require a cut down. They used to, and they do for anything above a certain weight. But as long as you keep it a very small payload, you don't have to do that, because your balloon will terminate itself, hopefully. But yeah, we would definitely have wished in many cases, and several cases at least, that we had terminated the flight before it got to the ocean or the Great Dismal Swamp. So I've been having a lot of fun with something called polyvinyl alcohol thread. It's a string that dissolves in water. They use it in the Orient for fishing. And I would take basically spools of rope hanging on the side of the payload and hold it on with that stuff. So if it lands in the tree and then it rains 2 days later, that ball of string will fall. And then you can use that in theory to pull the thing down out of the sky, but out of the tree. But yeah, there's a lot of little gimmicks like that, because it always ends up, especially in North Carolina, landing in trees. The people who do this in the Midwest landed in cornfields. So their thing is trying to locate a GPS or an APERS signal that is an inch off the ground in a cornfield. So there's a lot of fox hunting and all of that goes on out west.
Do you ever put, like, I know they have like these little like lost drone recovery beacons, which are a much more basically just a tone that you can direction find to more easily than an APR signal.
Yeah, and some of these, matter of fact, I've done one with this T-beam where I had a little piezo buzzer that I could turn on with a signal. Now, that was one that, of course, landed on the side of the road, so I didn't have to use it. But I could have sent a command to it, and it would send out an annoying beep to let me know which of the 5 trees it was in. And I've also had one that turns on strobe. If I'm launching and I'm afraid it's going to be too dark when it's coming down, I can turn on a strobe with it as well. So I've got ones that have little latching relays as well. So that's something that you can just send a command to it to turn it on, and it will stay on even if the battery on your microcontroller dies. It's because it's a latching relay and you're running a strobe light. The strobe light will continue to operate off of its battery. So yeah, there's all sorts of stuff like that.
But Paul, I don't think we've really lost that many, right? You did about 100 balloons, and we've done 5.
Yeah, I've lost. Yeah, I've done about 100. I pretty much always found them. There's one that disappeared about 30 seconds after launch, or a minute after launch, and that one we really don't know what happened. Something just completely shattered it. Hopefully it wasn't ingested by something, but other than that, it's always been the problem of, yeah, we know exactly where it is and it's right in the worst place in the Great Dismal Swamp or something like that. So I've gotten to the point now that I will try to land around Wilson, Farmville, Greenville area has a lot of tobacco fields. So if I do my plot and I know I want to launch at a certain time and I really want to land in that area, I will move my starting spot around. I'll go to a park in Siler City or Hillsboro or something like that and launch from there, so that the landing will put it in my sweet spot in eastern North Carolina where all the tobacco fields are. Now, it'll still land in the swamp or in the tree, but it'll be right on the edge of a nice tobacco field.
there any more questions?
Yeah.
Shannon, do you have a question?
Yeah. What what ham bands are you guys normally using?
I use, of course, 2 meter with APERS. So a typical flight will have a 2 meter, it's 144.390 for APERS. It's a national APERS frequency. And then I'll have a secondary transmitter just in case you gotta, have a backup. And let's say it's this one. This is anywhere in 70 centimeters. So I usually put it at 430.250 or something like that. And with LoRa, it's you can set how wide you want your spread spectrum to be. So if there's noise or interference or something like that, you can still get data in. So I usually do 2 meter and 440 on a single flight. It's pretty straightforward. Yeah, if it's somebody that doesn't, is doing a flight and they're not a ham, I'll use one of these 915s, and then they're out of luck for APERS. But yeah, just APERS is so convenient because everybody knows it, and it's just another system, and everybody's got eye gates for APERS running around, and various repeaters for that all around North Carolina and the whole country. So.
Cool.
Whisper, we use 20 meter just because it has really great propagation in the daytime and it has 0 propagation at night, and that's perfect for solar.
So when you send that thing up, there's just like a 20 meter wire, not actually 20 meter, but a 20 meter antenna just dangling underneath it.
It's a dipole of 16 feet on one side and 16 feet on the other, and that's it. The antenna, the active piece, goes up to the balloon, and the ground wire just dangles in the air. And then the 144 is another piece of wire, which is dangling there, so it uses the ground.
So your string to the balloon, between the balloon and the transmitter, is basically one half of the dipole. Okay.
Yes, it's real thin bell wire, like 28 gauge bell wire, support it with a real light fishing line, 6 pound test fishing line. And that's it. And it just, because it's going so slow, and once it gets up there, it's riding with the wind, its relative velocity to anything around is 0. So it's not really getting jostled around until it gets to a storm.
Yeah, if it gets sucked into a storm, it's pretty much toast. But one of the things that Tim does that I find just fascinating is we think, okay, that's going to be up there for several weeks, swinging back and forth, a piece of bell wire. What is the metal fatigue on a piece of 16-foot bell wire dangling below a payload as it's swinging on a balloon for several weeks? So I think, Tim, you came up with like some stranded wire that you used as like a strain relief and all of that.
Yeah, the best strain relief I found was Apple USB cable. So we just take an Apple cord from an old Apple phone and slice it up and use that wire. That's very good for, it's very ductile. We put about 2 inches of that between the hard point on the payload and the wire itself. The problem I did forget to mention, when I bought those solar cells, I was told that because of the UV up there, they'd only last about 60 days. And I actually coated it with some UV resistant spray, but the whole project only lasted 60 days. I mean, it transmitted for 60 days, and like on the 61st day, it stopped. So I don't know really why it failed, and there was no indication that the solar cells were like decaying, but it just never woke up on the 61st day.
Wow. How many times did it go around in that 60 days?
5 times around, and then on the sixth leg, our last real transmission was in North Africa. There's a little island off of the coast of North Africa that has a APERS station. We picked it up there, and then really weird, like 2 days later or 3 days later, we picked it up in northern Siberia, up in the Arctic Circle, and then that was it. So that we think it had to be some mistransmission because just the jet stream, there was no way the jet stream could have taken it up there in the amount of time that it had. But it just was a mystery we'll never know the answer to.
Yeah. May have been on the top of a sand dune in Morocco and sent a errant signal and managed to get received and with errors in it or something. That it was amazing. It was amazing. We're getting up every day and finding that it's still alive and transmitting, and then, oh, it's going across Nepal right now, and soon we'll be coming into China, and it knows it's over China, so it switches to China's APERS frequency and starts transmitting. So you're flying over a city of 1 million people in China, and it's picking it up as you're going across, and you're getting precise telemetry from APERS, and then it drifts out into the ocean, and we switch back to Whisper, and then we pick up a few packets over Japan, and then it's back out over the ocean, and we hear just through Whisper general areas as it's, oh, it's, you know, it's halfway to Alaska or whatever. It's a blast.
Some neat facts. It flew within 50 miles of Raleigh on one of its waves.
Nice.
It within about 100 miles of the guy who invented that board in Turkey. And it flew within 50 miles of Wuhan, China, right when COVID started kicking in.
Oh my gosh.
Really weird, really weird. And it almost got over North Korea, but didn't. We were worried about that.
How do you visualize the data, you know, as you're tracking it? What software applications do you use for that?
So the Whisper guys have their own server, and I think Paul might have shown it up there, but you can go just type in, I think, Whisper, and you'll get to their server, and you just pick a band, pick your call sign. That's it right there. That's the graphical based, or that's like both of them actually. So now in order to plot it though, so they show you your location, and then we pull it into, I don't even remember how we actually got that plot. Do you remember how we got the whole round the world plot?
Yeah, and you're getting grid coordinates, so you then have to look up and average your grid coordinate to get your latitude and longitude, and you can throw that into whatever. In this case, it looks like they plot into Google Maps themselves.
Right. So the thing with this, because it was really designed for attenuation type thing, you know, checking the atmosphere, you only get one dot. So their map that the Whisper page shows you is just every dot, you know, where it's at. It doesn't give you a line. So we have to put it into some, you know, like Google Earth or something, but we just gather it from the spreadsheet text and just plot it.
Yeah, I thought I saw in one of the visuals like a plot of over like Google Earth with altitude.
That was right there, Paul, right after the same slide.
Yeah, that.
Yep. And that's habhub.org. Let's see if there's anything flying over us right now. So if you go to HAB, again, high altitude balloon.hub.org, and go to tracker.
So this is for, APERS. This is APERS tracker.
Okay.
Yeah, and we feed in other stuff too. So we have LoRa now feeding into it, and they have a few Whisper feeding in as well. It's kind of crude, but so let's see. There's not that many balloons, but there is a one of these around the world balloons that's over. It's over. What is it? What's the call sign? W5KUB. It's flying over Lake Michigan at the moment. So, you know, that's decent. And of course the site, kind of like APERS, will show your radio horizon and all of that sort of stuff. So you can see, you know, watch all of these as they're traveling around the world. Some of these will be just the simple balloons that go up and come back down, and others will be the ones that are going around the planet. So that's a cool way to see this live right now.
Yeah.
So that W5KUB-110. Let's see, when did that telemetry came in? 11 minutes ago, probably as it was going over Sheboygan or, you know, someplace there by Green Bay. It was picked up. You've got latitude, longitude. Its altitude is, well, let's see. Let me switch it into freedom units here. 42,000 feet.
Freedom units?
Yeah, sorry.
Non-metric?
Yeah, I do everything in metric, and I require everything on NC Near Space to be in metric. But in this, you can go to the gear up in the corner of this website, and and click on imperial units and turn those on and get that. But, you know, it gives you all your coordinates, when it was last received, who it was received by, and so on. This was an APERS that was picked up over Washington. So you can also look at the path, and there's a button there called High Split, which I should really be sharing this. Let me split this, because, you know, we're talking cool gear. So maybe you guys are seeing this now.
Wow.
I've turned on, you know, here's this balloon in question with meters. Let me, again, I'll turn on imperial.
You can keep it in meters, like,
and yeah,
we
it's
can- we can
42,000
understand the
feet
metric system.
for people who are, you know, struggling. It's 42,000 feet. And if you turn on, hit the high split button, which is a meteorological term for, it basically is a series of runs, calculations of future paths based on a range of altitudes and models, computer models. So it will show where it thinks that is going to go next. So that's pretty cool right there. So you can see over the.
Do you use that for retrieval in your projects too?
Well, for my project, it will do it automatically. So do we
okay.
have one? Oh, this guy. What's this guy doing? So normally on a balloon flight, you'll see its path. This is just a balloon going up and back down. You'll see this lighter color with a target. That is the website's calculation of where it thinks it's going to land.
Okay.
Which looks like in the middle of a forest. So that sounds right. Now, I also transmit, again, using this Dave Akerman's code, I transmit down what the onboard Pi or Arduino thinks is going to be a landing spot also. And I find that it's a little bit more accurate because it's using the information from its launch. It keeps track of all of this on its way up, and it uses that to calculate on the way down. So you don't get anything until after burst, but then after burst, it will put a big red X on the map and show you where it thinks it is going to land. Now, what I want to do is have it look at some kind of version of the map that it has on board. And if it sees that that X is in the middle of a forest or something like that, then maybe it can make a decision of some kind on what it should do. But that's kind of an AI, you know, I'm thinking of all the different ways I can code that, you know, to do that sort of thing. But yeah, for the simple up down balloons, you get these little projections. And that's basically done by the browser. It's actually code on your own desktop that is calculating that. So some of these are floating ones, you know, and this one thinks it's going to land over here at past El Paso, but it's, again, I just pulled this data up. It hasn't traveled too much, but you can also see over here on the side, some of these balloons are on their way up and some are on their way down, and some are just floating. So yeah, we got a handful up right now. And of course, Europe has a lot of these LoRa receivers, as these little antenna towers are showing. So as opposed to apers.fi, where you have, you know, it's that's a little bit different, because you've also got everybody's weather station and you've got all the cars driving around and other stuff. And that's a shopping cart. Okay. Somebody's got a shopping cart as their
HamFest.
Oh yeah, that's RARS. That's perfect for RARS Fest. So, so that kind of gives you an idea, and you have to go through here and filter out stuff. But again, you'll see us on here. Sometimes I'll have an APERS transmitter in my car, but more likely I'll be over on to HamPiE, and then within HamPiE, you have the capability of turning that on. For instance, if you're on a mobile device, you get a button over here to turn that on. If you got something that with a GPS position, if it knows its position, you'll have a button. You can turn it on, and now your car will show up on the map. So that's how we get the things that you were seeing on the other slide.
You know, once I learned that, I had fun occasionally when you'd put on the listserv, hey, we've got a flight. I just like click HamPiE, I'll be like, oh, the chase cars are getting really close right now.
Yeah, and that's when you're screaming at the screen, no, you should have turned left, because you can see it in real time. They're seeing it, and maybe, Eastern North Carolina, you might be in a cellular dead spot. So you have to drive somewhere, get a signal, figure out what the new point is, and then travel on. So Tim and I have dealt with that a lot. I have to figure out where the thing is landing. All right.
Hold on. I thought my thing was plugged in. Hold on. I just got a low battery warning, and all of a sudden I was like, wait, you're plugged in. No, I didn't actually plug the other end in.
Well, this is cool. I would love to see this like up close and personal, because yeah, I do ham radio, but I'm really not a good electronics. I'm not really good at electronics and stuff. Like, I have to see it in person and like, have someone explain it to me. But this is really, really cool.
Super cool.
Yeah.
Yep. And it's very doable. There's no reason why any of you guys can't do this. So,
I mean, I'll give a plug. Join the Google group, and then anytime they have a launch coming up, they say they will, and you can go help them, and it's a ton of fun.
I want to go. So cool.
Yeah, Aurora, do you have anything you can share from your research on your flight?
Yeah, so I don't remember how we met or how I discovered you. Maybe it was at one of the
Maker Fair or something.
I think it was one of the Maker Fairs. And I was trying to figure out a way to do budget space biology research, basically. And so I sent up some yeast samples, trying to replicate an experiment that someone who was a high school teacher had published on kind of like an education journal of like a way to do high altitude ballooning as biology experiments. And it's basically you take this yeast, and it's a mutant that is pink when you grow it on a particular diet, and occasionally it'll just revert back to wild type. And my question was basically like, there's a couple different ways you could send it up. A, will it survive? And B, will we have a higher mutation rate with things that are sent up, presumably where there's higher radiation than things on the ground? The answer is no, nothing mutated at all. It still stayed pink. And I don't know whether which was different from what the paper I read was. They actually saw a higher mutation rate, but I think launched theirs did a much higher point. And we were like at the nadir of the solar cycle when there was like no sunspot activity at all. So it'd be fun to repeat sometime. But we also learned that no, you can't send it up on plates. It has to be a kind of in an inactive form, just suspended in water, because the plates will depressurize enough to kill all the yeast that was on the plates died. That was like actively growing. But the stuff that was in little lightweight bags, some of it leaked out because of depressurization, but enough was left alive in there that we could get culture from it. So that was useful to know, because it's the lightest weight version worked the best. Yeah, and it was a lot of fun. And for ours, I would like to say, did not actually land in the tree. We could have landed in a swimming pool or a tree, but we landed in someone's yard right in between those things. So luck of first beginner's luck that it actually worked out, and it was a lot of fun.
Cool. We still have a balloon in my garage.
Oh, you still have a balloon in your garage?
Yeah, we never did that thing, and I haven't given it back to Dave yet.
Well, so we can find more uses for your balloon.
Yeah.
Well, now you know that if you release one of those Mylar party balloons, that it could be up for at least 5 weeks going around the planet. So
that's crazy.
Yeah. So feel sorry for those sea turtles that eat them, but yeah.
Yeah.
Well, this was great. We were at 3, so we are kind of at time. If folks want to stick around to work on things, they're welcome to stick around and chat. I have to go pretty soon because it's my husband's birthday and I have birthday festivities duties. But Paul, Tim, thank you again. This was fantastic. I have a feeling you'll have a few more subscribers to your Google group after today.
Yeah, I already joined.
Me too.
And hopefully perhaps we could maybe collaborate on some more flights in the future.
Absolutely.
Yeah.
It's getting towards summer. It's flying time, so let's do it.
Right.
Yeah.
Right. See you guys.
Again.
Bye.